Hi guys, welcome to this page of the notes, and again what we're doing here is we're just running through some general trends when it comes to graphing polynomials. This giant paragraph right here essentially just restates everything you guys just saw in the last page of the notes in that chart where you have an even degree polynomial, and what it simply says is if the leading coefficient is positive, both ends will go to positive infinity. If the leading coefficient is negative, both ends will go to negative infinity. What I want to do is point out one more quick little note to you guys here, and we'll write it right here. This is a really important note. When you have an even degree polynomial, an even degree polynomial must cross the x-axis an even number of times. Or not at all. Okay, so an even degree polynomial must cross the x-axis an even number of times, or it's not going to cross at all. This is actually a really great way to check it. If you have an even degree polynomial, and your polynomial crosses the x-axis 3 times, you know you done goofed, right? You made a mistake, because an even degree polynomial must cross an even number of times, or not at all. So here's what we see here. I've given you a couple of example problems right here. What I've got is an even degree polynomial. I know that because both ends are headed in the same direction, so it must be an even degree polynomial, but it doesn't cross the x-axis at all. This one right here, both ends are headed in the same direction, so it's got to be an even degree polynomial. And in this case, I cross 4 times, and so I have 4 real zeros. So the degree is even. I cross an even number of times. Awesome. And then this one right here, again, both ends are headed in the same direction, so it's got to be even degree. But what you'll notice here is that I only have 2 real zeros. But look at all these turning points, right? I got a bunch of turning points here. Well, what that means then is even though the degree of my polynomial is 6, and I have 6 zeros, only 2 of them are real. Remember, the degree of the polynomial is equal to the number of zeros. That was on the last page. Since my degree is 6, but I only have 2 real zeros, how many of them must be imaginary? Well, yeah, you got to have 4 imaginary zeros, right? Because the number of zeros is going to be equal to 6, and since 2 of them are real, that means 4 of them have to be imaginary. All right, so one last thing right down here at the bottom, again, just for even degree polynomials, this is just restating what I said in the chart. There's just one quick little typo here. I forgot to put a minus sign right there in front of that infinity symbol. That should be negative infinity. But other than that, it's just restating what was in that chart on the previous page. Same thing here for the odd degree polynomials. Again, I'm just restating what was on the previous page here in this giant paragraph. When the leading coefficient is positive, right, the left-hand side will go negative, the right-hand side will go positive, right? So when the leading coefficient is positive, right-hand side goes positive, left-hand side goes negative. When the leading coefficient is negative, the right-hand side will go negative. On the right will go negative. Left side of the graph will go positive. All right, so it's just restating all that information that was in the chart. I just want to make a quick note here as well on this one, and that is that we're on odd now, sorry. An odd degree polynomial will cross the x-axis, you guessed it, an odd number of times. but it must cross at least once. So again, what we've got here is I give you a couple of graphs. You know that they're all odd because the ends are headed in opposite directions. What we have here is a third degree polynomial, but I only have one x-intercept. That means one real zero, but it's a third degree. So how many imaginary zeros do I have? Well, I know the degree has to be equal to the number of zeros. Since I only have one real, there's got to be two imaginary. Same thing here, I have a third degree polynomial, but I cross the x-axis 3 times. So since I have 3 zeros and all 3 of them are real, I don't have any imaginary. And this one right here is a 5th degree polynomial. 1, 2, 3, 4, 5. I cross the x-axis 5 times. Since it's a 5th degree, and I have 5 real zeros, I don't have any imaginary. Also, right down here at the bottom, I have once again just sort of restated all of that information given to you back on that table about the end behavior of these polynomials, just written another way if you like this better. So guys, now what we've come to now is we sort of have all this conceptual information about graphing polynomials. What I'm sure you're most concerned with is how am I going to be asked to represent this information in a problem. So head on over to the next page of notes. We'll take a look at the kinds of problems you can expect to see, and I'll meet you guys there.